When we design any member using AISC 360 code, we need to check for lateral torsional buckling depending on section type and nature of bending. The nominal flexural strength for lateral torsional buckling depends on a modification factor CB, which further depends on bending moment profile, and if any incorrect value is used, that will affect the bending capacity and interaction ratio. Do you know how easily we can calculate this factor and use it for design? Hi, I am Surajit Ghosh, and in this video, I will discuss about a custom template which can calculate CB factor for any physical member and load case present in a STAAD model and assign this parameter to those members. I have already published a detailed video on CB, how this factor is calculated depending on moment profile, what is the correct way to define this parameter in a STAAD model. You can check that video for more details. CB is a modification factor required for lateral torsional buckling strength calculation for any section like doubly symmetric eye, channel or hollow section, and calculated strength is directly proportional to this value. CB is calculated using equation F11 of AISC 360 16 code, and it depends on maximum moment and moment at quarter points. When bending moment is uniform throughout member length, all these moments are same and this factor becomes 1. But for non-uniform moment profile, we need to calculate CB using this equation, considering moment at different unbraced location. For any structure, uniform moment profile is very rare, and for most of the gravity and lateral loads, bending moment varies along length. That's why we need to calculate this CB factor considering correct moment, and as moment value depends on applied load, CB must be calculated separately for each design load case. For any medium or large model with several hundred member and load combination, it's almost impossible to calculate this factor manually for all the members. There is a way to auto-calculate this during design using CB0 parameter. For this input, during member design, program calculates the factor automatically for each load case. This seems like a nice approach, but there is one problem. As STAAD performs member design for analytical member, correct moment value is not considered for CB calculation when unbraced length is different from member length. For example, consider this 3 member with intermediate support to web, but this member don't provide any restraint to compression flange. So entire member between this column is unbraced against lateral buckling, and full length must be considered for CB calculation as per equation F11. We have divided this beam at intermediate level for proper connection, and if we design these members using CB0 parameter, program will calculate CB value for individual member considering member-wise moment value. Though we can specify the length of LTB using UNT, UNB or UNL parameter, it is not considered for CB calculation. Here comes the problem. Maximum and quarter point moment for entire member are different from an individual member. Just check the moment at quarter point between these two members. It is not same, right? During auto-calculation of CB factor, it is calculated incorrectly as result of individual member is considered, and this produce incorrect bending capacity and design ratio. Only way to rectify this? Use a conservative factor, 1, or manually calculate the factor, which is time consuming. To minimize this effort and consider correct CB factor for design, I have developed a custom template with VBA using few OpenSTAAD functions which can extract relevant information from a STAAD model. We need to provide few inputs, and based on that, it will automatically calculate and assign CB parameter to different member. First, we need to select the loads which are used for design. It might be all loads present in the model, only load combinations, or a fixed set of loads which we can specify here. Next, we need to provide member information. Note that this code is developed only for physical member. If we generate a STAAD model using physical modeler, then all physical member information is available in the model. If it is generated using analytical modeler, either we need to create this physical member manually, one by one, or use the form member option to auto-generate physical member from analytical data. Physical member is required to inform program about correct unbraced length and which members are combined as a single entity during LTB check. We can further enhance this template to assign UNT-UNB parameter as well. We can use all physical members present in the model or use members with a specific material. This option is useful for any composite type of structure with both concrete and steel member, like a concrete building with steel roof. Also, we can provide member number as an input. This template can be used to calculate CB value, or we can use it to calculate and assign CB parameter to member. During calculation, relevant moment values are extracted for each physical member for each load case, and CB is calculated for each load separately. We can find this report in detailed result page, which we can switch on using summary plus detail option. For all selected loads, CB is calculated separately based on moment and reported in this table. In STAAD, it is not possible to define separate CB value for each load case. We can only provide a single value and it will be considered for all loads. That's why minimum value among all this is calculated and reported in the summary table. This is the CB factor we need to consider for design. Though it is in conservative side, right now this is the only option and it is better than using the factor as 1, which is much more conservative. For manual calculation, we can use individual CB factor. Finally, we can provide few information about design block. We can add this parameter under any existing block or create a new design block for AISC 360-16 code. Note that value of CB parameter is reset to default for any subsequent design block. Let's check this model and see how this works. I have generated this composite model in physical modeler with concrete beam and column till the ground level, and steel sections are used in the superstructure. All these members are created as a physical entity from end to end without any intermediate joint. Intermediate connections are created by the program during analysis. So we have all physical member information and we can use this for calculation and assignment of CB parameter. Check the analytical model generated in the background. No design block is present in the model and we can create a new one. There are 17 load combinations and I want to use all this for CB calculation. For concrete member, CB is not required and we can filter this using material option. Only for members with material steel. First, I want to calculate and check CB factor using this option. Simply click on calculate and this will generate a summary table for all physical members. Analytical member information is also included in this table so that we can cross-check or manually assign these values. In this table, minimum CB factor considering all load combinations are reported for each physical member of this model. We can eliminate this step and directly assign this value as CB parameter. For that, we need to select Calculate and Assign option, select a new design brief, and click Calculate tab. First, this code will calculate and report the factors in tabular format. Along with that, it will create a new design block for AISC 36016 code and assign CB parameter to all these members. For example, check physical member 55. It is formed with analytical member 55, 250 to 256. For this member, CB factor is 1.529. If we check the STAAD model, design parameter list, same value is assigned to all these members. Easy, right? We can also cross-check the detailed calculation table to validate all these values and compare it with STAAD output. By the way, OpenSTAAD function works with the base unit setup, and depending on metric or English unit, it extracts the result. For this model, I am using metric unit system, which we can cross-check from here. We can use this template for any STAAD model, either to calculate CB value using analysis result and use it for manual calculation or in-house program for design. Also, we can auto-assign these values to STAAD model for member design. That's all for today. Let me know your view about this template. Thanks for watching.